Okay, in number 5, we have the KSP for the PBCl, and it says calculate the equilibrium concentration of PB in a 1 liter saturated PBCl solution. So we had it was at the perfect equilibrium that we added 0.250 moles of NaCl. So it was at perfect equilibrium, the K was being satisfied, and then we added Cl. And so as a result, we don't care about the sodium, but with more Cl in there, less lead will be able to be dissolved. So what's going to happen is the system is going to consume a little bit of the chlorine and the lead so that it can reestablish the K. So what we have here is an ice situation, PbCl2 and Pb. Okay. We know that the Cl is now going to be 0.250, and we want to figure out how much of the lead will be able to remain there. So we can pretend like we're starting all over again, and we know that we have enough lead chloride for it to dissolve. It's a more than saturated solution now. So we can pretend like we have 0, add x here, add 2x, and then 0.25 plus 2x, neglect because 5%. And what we get is the KSP, which is 1.6 times 10 to the negative 5th, has to equal whatever the new lead is times 0.25, because that's the new chlorine, squared because it's still Cl2. Okay, notice we don't multiply the 0.25 times 2, even though there's like a 2. It's because the 0.25 is what's in the beaker, and that's all that's in the beaker, so that number has to go there. Okay, so now we find that the amount of lead that really will be allowed to dissolve in this situation is 2.6 times 10 to the negative 4th molar. Because it had to adjust with too much chlorine. And then the last part here, if 0.1 molar NaCl is added to 0.12 molar AgNO3 and 0.15 molar PbNO3, which one is going to precipitate first? So we can do a calculation. This is just like our quiz. We don't care about the chlorine. Nope, sorry, we don't care about the sodium. We don't care about the nitrates. Right now we know the KSP of each of these because it was given. The silver is 1.8 times 10 to the negative 10th. We know the silver is 0.12, and we know, well, we don't know how much chlorine we'll need to make it precipitate. Same thing, we know the KSP here of the lead is 1.6 times 10 to the negative 5th. We know that there is 0.15 of the lead. We don't know how much chlorine we're going to need to add, and this term is squared because there will be a 2-to-1 ratio. Chlorine is -1 and lead is +2. So when you solve these, you should end up finding, I believe, that, here's the work, you should end up finding that we need a lot, let's see, the Cl will reach a concentration of 10 to the negative 9th. We need a lot less Cl to make the AgCl than we do for the lead. Okay, so that's this problem. Last point, the reason this is X and not 2X is because the chlorine is coming from this new salt. Okay, it's not coming from putting lead chloride in the beaker. It's coming from this new salt. We don't know how much of this new salt we need to put in. We don't care about, like, yeah, the 2 doesn't matter. I don't know how, but yeah. All right, bye.